Electromagnetic waves can be transmitted to empty space, and they are transverse waves. They transfer energy from one point to another, um, and they have a dual nature, particle nature, as well as a wave nature. Those are some of the properties of electromagnetic waves there. 10.1 says defining electromagnetic waves. Electromagnetic waves, 10.1. 10.1 electromagnetic waves are waves of changing electric and magnetic fields, waves of changing electric and magnetic fields that are mutually perpendicular to each other and to the direction of propagation of the wave then, right? Soldiers use night vision devices to see objects at night. Name the electromagnetic radiation. Name the electromagnetic radiation used to detect objects in the dark. The electromagnetic radiation used to detect objects in the dark would be infrared radiation there. Give 3 reasons why ultraviolet light is important in our daily life. The applications of ultraviolet radiation would be firstly to detect counterfeit money or passports, and to sterilize hospital equipment, to also for forensic investigation there. Right. 10.4 says now calculate the energy of a photon of light with a wavelength of 700 nanometers. Excuse me. So we have a wavelength of 700 nanometers. Let's convert that to SI units, to meters. Is going to be 700 multiplied by 10 to the power of negative 9 meters there. So what we have here is that we're going to be having energy is equal to Planck's constant, the speed of light in vacuum, divided by the wavelength. Let's substitute here. We're going to have 6,63 times 10 to the power of negative 34. C is 3 times 10 to the power of 8 all over 700 multiplied by 10 to the power of negative 9 there. And this is going to be, in the calculator, we have 6,63 times 10 to the power of negative 34. 3 multiplied by 10 to the power of 8 over 700 multiplied by 10 to the power of negative 9, giving us a 2,84 times 10 to the power of negative 19 there, joules there. 5. Okay, let's see. 1, 2, 3, 4. Seems fine like that. And 10 for this one there. And 10 for this one there. And because we have here wavelength, we can go from wavelength to frequency and from frequency to wavelength back and forth. Having been given a wavelength of 700 nanometers there, which is 700 multiplied by 10 to the power of negative 9, there could have been a question saying that we should calculate the frequency. So we would say the speed of light is equal to frequency multiplied by wavelength. The speed of light is 3 times 10 to the power of 8. We are calculating the frequency, and the wavelength is 700 multiplied by 10 to the power of negative 9 there. And to solve, divide here by 700 times 10 to the power of negative 9. Divide by 700 multiplied by 10 to the power of negative 9 there. And it will cancel over here. This will cancel over there. And the frequency will be equal to 700 3 multiplied by 10 to the power of 8 divided by 700 multiplied by 10 to the power of negative 9 there, and our answer would be 7.29 multiplied by 10 to the power of 14 hertz there, just in case the question says calculate the frequency there. Okay.